and I will be sharing my screen at this time. Okay, everyone should be able to see at this time our opening screen on our presentation. It says HMH7 SEER heat pump overview, our first screen. Can everyone see that screen okay?
Yep.
Okay,
Yes.
well, fantastic. We'll go ahead and get started then this morning. One of the first things we always like to talk about with our new HMH7 SEER product is the fact that it is a little bit different than our other champion products. It's not bad, it's just a little bit different. One of the things that we'd ask everyone to please remember is that unit service fittings are actually 5/16 flare. And this is not uncommon. You'll see this sometimes on mini splits. One of the things I want to stress at this point is our unit is definitely not a mini split. You're going to install it and treat it just like any other heat pump. You'll have a suction line, you'll have a liquid line going inside to a conventional air handler. And please write this down or make a note of this. It's going to be a conventional TXV on the indoor coil. Let me say that again. It's going to be a conventional expansion valve on that indoor coil. So it doesn't have to have anything special. It doesn't have to have an EEV type of expansion valve on the indoor coil and so on. In addition, it does require a 5/16 adapter down to the 1/4-inch service hose on the technician's gauges. And here we just have a little picture of what that looks like. I think this might be a Yellow Jacket brand or a Robinair. I'm not sure where I pulled this picture, but you'll notice it's 5/16 on one end that hooks up to the unit, and the other end is a 1/4-inch male flare that'll hook up to our service hoses, so the technician will be able to use his normal service hoses on his gauges with this adapter. But please, if you're selling this equipment, make certain that you've got some of these adapters on hand, because they will be necessary to service the unit on the refrigeration side. Any questions or comments on that? Everybody good?
Yep.
Okay. All right, well, at this time, we're going to be discussing the low voltage wiring and the setup of the HMH7 heat pump. And we're going to start out with an AE air handler, which features a standard ECM type motor. Now, some of the key subjects we will be talking about specifically is going to be the low voltage wiring with an AE air handler. And what I've done is I've created a simplified block wiring diagram for these sessions. Now, the AE air handler has no physical terminals, but it's equipped with pigtail connections. So just remember, as a technician, they're going to have to go in and make these connections up with wire nut connectors, because there's not going to be a hard physical terminal on there like we would see, for instance, with our furnace product. Okay, it looks like I've lost my screen. Did everyone see my screen drop out as well?
No, you're good to go. We can still see your slide.
You
Yes.
still can, okay. Well, I'm not sure why I can't see my slide. Give me just 2 seconds here. I might have touched something. There we go. That looks like that's going to be better. We're also going to talk about the wiring of an accessory single pole double throw relay in the indoor unit and how it's going to be used for airflow reduction. Now, we're going to recommend kit number HMH7A K001, which is a relay kit that's going to be necessary for the install of this unit. Now, we're going to recommend this kit because it is for convenience, as well as the supplied parts that come in that kit. Now, just as a quick overview, all of these kits that we're talking about, the 001 and the 002 kit, it's a relay kit, but in addition to the relays, you're going to have a bi-flow filter dryer. You're going to have some screws to make it convenient to hook it up, as well as you're going to have some wiring harnesses that are going to be pre-wired and ready to go. So basically, that we do recommend the kit. Now, the obvious question is, well, what if we get in a situation where we don't have any more kits? Can the contractor still hook it up with just a standard single pole double throw relay? Sure, he can. Can he provide his own bi-flow filter dryer? Well, yes, he can. And can he make his own field wiring? And the answer is, of course, he could. But the point is, these kits make it really, really convenient. And so for that reason, we do recommend these kits. Now, it should be noted that the HMH7A K002 kit can be used on any of the HMH product. And with any of the indoor product, it's kind of a universal kit. The 002 is a universal kit. The 001 is going to be specifically for the standard ECM motor product, which we'll get into more in a little bit here. But just remember, the 002 kit is universal. It'll work on anything, but the 001 kit will only be used for the standard ECM motor, like an AE air handler or a TME or a TMY furnace. And again, we'll get more into that in a little bit. Finally, another key point we need to remember too is the heat pump thermostat that we select. And just use your favorite heat pump thermostat. That heat pump thermostat has to have a BO selection for reversing valve operation selection. Now, what I mean by that is this unit, our HMH7 heat pump, is the only product in our Champion lineup that's going to use the B terminal to energize the reversing valve in heating mode of operation. Let me say that one more time. It's exactly opposite of all of our other Champion heat pumps. It's not bad, it's just different. And so we want to remember that that is going to energize the B terminal in the heating mode of operation. Any questions or comments so far on what we've talked about? Is everybody good?
Hey, Joel.
Yes.
Kind of a leading question, but also just for my further explanation. As an example, and maybe you're going to get into it later, but for that 002 kit, can
Yes.
you reference a couple model numbers that you're, as an example for when you
Yes,
say?
I can.
Okay.
That's an excellent question. So the 002 kit is required for any of our variable speed indoor products. That would be like an AVC air handler, or it'd be like a TMV, the TMV variable speed furnace model. So any of the variable speed indoor product will require the 002 relay kit. That's an excellent question, Dave. Thank you.
Hey,
Any other questions?
yeah,
Go
just
ahead.
one other. What about the TM9Y and or the TM8Y, which are big movers for us?
You'll be able to use the 001 relay kit because those products that you mentioned have a standard ECM motor. It's not a fully variable speed motor, it's a standard ECM motor. There you go. Okay. Good questions, everyone. At this time, let's go ahead and look at the simplified block wiring diagram. We're going to start with just a standard 24-volt heat pump thermostat. And again, your favorite thermostat, as long as it has the B terminal. And we're going to be discussing an AE air handler in this first segment with a 2-stage heat strip, and then our heat pump outside. So from the B terminal, we're going to go straight outside. We're not even going to touch the air handler, so to speak, because there's no terminal on there for that. But when we energize that B for reversing valve, it will be in the heating mode of operation, and the thermostat has to have that BO selection. So B goes to B straight outside. W2 from the thermostat goes to W2 on the second stage auxiliary heat on the heat pump. So again, this is a pigtail, so they'll make it up in a wire nut. W1 from the thermostat goes all the way through from the thermostat to the indoor unit to the outdoor unit to the W terminal on the outdoor unit. Now, one thing we'll discuss a little bit in a few minutes, but we want to make sure that we make this connection inside on the air handler, because this is going to not only provide first stage auxiliary heat when the thermostat calls for it, it's also going to provide auxiliary heat input when we go into defrost from the outdoor unit. That's why we tie it to the W outside, so that we have an input for the heat strip during defrost. Because remember, team, whenever we go into defrost on a heat pump, we're actually going back into the air conditioning mode. So in the middle of the winter time, we're going into the air conditioning mode to defrost the outdoor coil, and we have to bring on some auxiliary heat so we don't freeze the homeowner out when they go into air conditioning mode in the middle of the winter time during defrost. Y terminal is our compressor coil. So Y from the heat pump goes straight outside, and you're going to note something. On the AE air handler, it's typically going to be wired with a factory yellow wire on the motor itself. That's going to have to be removed. So let me say that again. We want to make sure and remove the factory yellow wire going down to the ECM motor during install, and then we're going to have Y from the heat pump thermostat going straight outside. C is our 24-volt common, And that 24-volt common wire will go from the thermostat to the indoor unit to the outdoor unit. That's our 24-volt common going all the way through. Our terminal is a 24-volt hot connecting the thermostat and the indoor unit. This is the power wire that we're going to use from the indoor unit transformer to power up the thermostat and to have our low voltage hot, so to speak. Now, I should note that this R does not, let me stress this one more time, the R does not go outside to the HMH heat pump. It uses a different wiring scheme, it uses a different control protocol, and it does not require the R terminal to go outside. And again, this is totally different than any of our other Champion products in the fact that we normally have the thermostat and the indoor unit and the R terminal going outside to power the board up outside. Well, we don't do that with the HMH7. E is our fan call. And what we're going to typically do with an AE type of air handler, we're going to have that G call. We're going to select the lowest speed tap on the ECM motor in case the homeowner wants to run some indoor air quality products. And they want to have that continuous fan at a low airflow. So if they call for G only, whereas if they go to the thermostat and they select fan on, from auto to on, how fast does it run? Well, we want to run at the slowest speed tap to give us some nice low airflow and nice circulation across those indoor air quality products. So typically the fan call will be the lowest speed tap on the ECM motor. And again, that's just a typical application. Any questions or comments so far on the basic low voltage wiring before we continue? Is everybody good? Okay, on the relay. So this relay pack that we have here would actually be the 001 relay. It's just a little single relay kit, single pole double throw relay. And what we're going to do, we're going to take one side of the coil, B in this example, we're going to take it to an S1 output from the outdoor unit. So as we start thinking about this relay logic, it's the outdoor unit that's going to energize this relay to switch those contacts. The other side of the relay coil is going to go to 24-volt common, and so that completes our coil or the control circuit on this relay. So basically, when we get an S1 output from the outdoor unit, it's going to switch the relay. The common terminal on the relay is going to go to yellow, or the Y terminal for compressor. So anytime we have a compressor demand from the thermostat, we'll have 24 volts to the common terminal on the relay pack. Now the ECM motor, we're going to select a high-speed tap, and we're going to go directly from the high-speed tap, in this case it'd be W1, the high-speed tap going down to our ECM motor directly. This is going to be field wired. And what that's going to do, anytime we go into defrost or we have auxiliary heat call, we're going to command that ECM motor to go to high speed. This is very, very typical. We want to make sure we have, plenty of airflow when we pull in that heat strip and the unit's running outside. So we're going to take a wire directly from W1, our auxiliary heat tap, to the high speed call on the ECM motor. Now watch this. We're going to take normally closed contact from the relay over to the ECM motor, and we're going to provide a speed tap. We're going to select a speed tap that's going to provide 100% of the cooling airflow. Now remember, team, we're always going to set this motor up for 400 CFM per ton, 400 CFM per ton. So if I have a 2-ton unit sitting outside, I'm going to need 800 CFM. If I have a 3-ton unit sitting outside, I'm going to need 1200 CFM on this 100% cooling airflow tap. The normally open terminal on our relay is going to go to a speed tap. We're going to have to select a speed tap on the ECM motor that's going to provide 60 to 65% airflow. So here's the idea. When the relay switches, it's going to actually command low airflow. So let me say that again. Normal operation, the heat pump outside is going to have high airflow command. Then, when the heat pump outside makes an intelligent decision that it's going to reduce capacity, it's going to energize S1 terminal, energize the relay, and switch to low speed. As a matter of fact here, what we're going to do, we're going to go ahead and show you an animation at this time on the PowerPoint, and you can kind of see how that circuitry works at this time. There you go. So you notice we energized S1, we energized the relay coil, and we switched the relay from normally closed to normally open. And so now we're commanding low airflow. So this is kind of an interesting way to control it. Again, it's different than our TH16 product, which has a Y2 output commanding high airflow. This is exactly opposite. It's not bad, it's just different. And so the default on the HMH7 heat pump will be high airflow. And then as it sees capacity reduction, as the indoor space starts to cool down, as the suction pressure starts to come down, as the liquid pressure starts to come down. In other words, when the outdoor unit monitors our refrigeration cycle and it says, hey, I've got reduced capacity now, I'm going to go ahead and command low airflow or lower airflow across that coil to meet that capacity reduction. So it's all about reducing the airflow and matching the capacity reduction on the new unit outside. Any questions or comments on that or how that's working? Okay. Please notice that if we do have a W1 or auxiliary heat call anytime, even if we're commanding low airflow, in other words, we have an S1 output from the outdoor unit commanding low airflow, even if we have low airflow command, if we get an auxiliary heat call during defrost or during an auxiliary heat call from the thermostat, it's going to energize the fan on high speed, and S1, our reduced airflow, will have no effect during defrost or during auxiliary heat call. We're going to go to high speed on auxiliary heat call. Any questions or comments on the relay logic we're looking at and the basic wiring of our AE air handler and our HMH7 heat pump at this time? Everybody good? Okay, well, let's go ahead and jump into a couple things we want to remember. W1 will be present again anytime you have an auxiliary heat call from the thermostat or during defrost cycle, as a quick reminder. Okay, at this time, let's go ahead and talk about that TME and TMY furnace, that standard ECM motor furnace product that Dave Draga was asking about a minute or so ago. So we're going to go over the low voltage wiring, just like we did wire for wire on the TME and the TMY furnaces. We're going to be utilizing the single pole double throw accessory for airflow reduction, just like we did before. It's going to be kit number 001. We can use the 001 kit to his good previous question for the TME and the TMY standard motor furnaces. Now remember, team, we can always use the 002 relay kit as a universal relay kit. However, one of the relays, specifically the RV relay, will not be needed for this application. So even though you can use the 002 kit, it's a universal kit. It works on anything. You will not use one of the relays on this application with the TME or TMY furnace. So the burning question becomes, hey, if I had to carry just one kit, what would I carry? I'd carry the 002 as a universal kit because it works on anything. Just remember, the contractors will only be using one relay if they use a TME furnace, a TMY furnace, or an AE air handler. Good. We still have to have that heat pump thermostat, that B selection for reversing valve operation. Please remember too, on any sort of dual fuel application, in other words, where we have a furnace and an outdoor unit together, we want to make sure and select the heat pump with dual fuel function when it's going to be used with a furnace product. Okay, at this time, let's go ahead and take a look at that TME single stage furnace with our HMH7 heat pump outside, a dual fuel application. You'll notice that we do have the 001 kit. In other words, we just have the single relay mounted in the cabinet inside. And very much like we had before, it's very, very straightforward. B goes straight outside, just like we had before. That's going to be for our reversing valve in the heating mode of operation. And remember, team, that thermostat has to have the BO selection to select the reversing valve for heating mode and dual fuel function on a furnace. Because we only have a single stage furnace inside, we're just going to use the W1 output from the thermostat to the W on the furnace to W outside. And just like before, Y goes straight outside. That's our compressor call from the thermostat to the outdoor unit. C is going to go all the way through just like it did before. That's our 24-volt common. Now remember, team, our terminal only goes to the indoor unit. It does not go outside. It's strictly from the thermostat to the indoor unit. And there's our G again. That's our fan call. Again, that's pretty universal and standard. Now you're going to notice on the TME furnace, the labeling on the terminals are a little bit different. Now we're going to be dealing with a Y1 and a Y2 terminal. Now, by the way, team, these are actually hard physical screw terminals on the furnace. So unlike the previous product where we had to make it up in pigtails, we actually have terminals now on the furnace that we can actually use to make up our low voltage wiring. So taking a look at our relay, we're going to take B terminal on the relay. In other words, one side of the coil up to S1, just like we did before. Very, very simple on the HMH heat pump. The A terminal on the coil of the relay will go up to C, just like we did before. And just like we had before, the common terminal on the switching contacts of that relay will go to Y, just like we had before. Now this is where it varies a little bit because, again, we have hard physical terminals on our TME furnace. The normally closed terminals, or the normally closed terminal on the relay, will go to Y/Y2. That's our high-speed airflow. That's our second stage cooling airflow on the product. The normally open contacts on the relay will go up to Y1. Now that Y1 is going to be our first stage cooling airflow on the indoor unit. So as we take a look at that wiring schematic or that wiring scheme, you'll see it's exactly like the AE air handler, except the terminals are a little bit different on the furnace, but it's the same wiring scheme as far as the relay application and how we hook the relay up. Is there any questions or comments on how we've done this as far as hooking up a TME furnace with our HMH heat pump outside? Okay. Well, team, I want everyone to please note something. Instead of going over all those wires again, the TMY furnace, please note the TMY furnace low voltage wiring and the relay wires are exactly like the TME, the furnace that we just did. It's exactly the same. The only difference is the TMY furnace is a two-stage heating furnace, and it's going to require a W2 and a W/W1 heating terminals. So the only difference between the TME and the TMY furnace is the TMY furnace is two-stage heat, so we're going to have a W2 input for second stage heat and a W/W1 for our first stage heat. So here we go. Our W2 is our second stage heat from the thermostat directly to the indoor product. It does not go outside. You'll note that the W1 from the thermostat goes to W/W1, which is our first stage heat on the furnace, on this TMY two-stage furnace, and that goes outside to W. So other than that, that's how it wires up between the two furnaces. Any questions or comments on how this wiring scheme is working with our relay and our TME and TMY ECM, standard ECM motor furnace product? Any questions or comments? All right, well, let's go ahead and look at the animation and switch that relay as we talk about airflow reduction with our furnaces. Again, it's the same scheme. We energize S1 outside, which means the HMH7 heat pump is commanding low airflow or reduced airflow. So it energizes the relay. It switches that relay to from the normally closed to the normally open contacts, and then it commands reduced airflow as it reduces its capacity. So what we're doing, team, is we're allowing the HMH7 heat pump outside to make intelligent decisions based on capacity and its point of modulation, and it's going to reduce airflow to provide extremely, very, very comfortable conditions, extremely comfortable conditions, humidity control, capacity reduction. So you're going to get more runtime, and I know that sounds counterintuitive, but we want more runtime to keep that humidity down and to keep that air moving and to keep that air nice and clean and crisp and fresh inside that house. And so this modulating heat pump is going to give that to us, but we're going to let it make some intelligent decisions on when to reduce that airflow inside to maintain optimal comfort and humidity control. Any questions or comments on this so far before we jump into some of our other applications? Everybody good? Tony, any questions in the chat box?
No, nothing has
Yep.
come up yet, Joel.
Well, fantastic. Well, team, let's go ahead and continue our training then this morning. So the next thing we're going to be talking about, we're going to talk about low voltage wiring and setup of the HMH7 SEER heat pump with a variable speed air handler and a variable speed furnace. Now, please remember, team, this is going to absolutely require the 002 relay kit. This requires the 002 kit. Now, the low voltage wiring with the variable speed air handler and furnace, that simplified block diagram, we're going to be going again wire for wire for wire. Now, please note the terminals are not used on the HMH7 outdoor. We're not going to cover the ones that aren't used. So in other words, you may have some terminals on the variable speed air handler. For instance, you might have your some of your dehumidification terminals, your delayed jumpers and stuff like that on the variable speed product. We're not going to dig into that indoor product that deep today on that control board, but there are other jumpers on the variable speed product that we're not going to touch on. For instance, another example would be like the HUME terminal or the DHUME terminals. That's not the function of this particular training today. That's a separate training session that we can always do, or the EAC terminals, electronic air cleaner terminals. They don't specifically apply to the HMH7, so we're not going to talk about those now. Again, we want to make sure that the accessory wiring relay kit HMH7 AK002, you have to use the 002 kit with the two relays on there in order to make this work properly on the variable speed product. Now, team, please remember this. The heat pump thermostat still has to have that BO selection for reversing valve operation. And we always want to make sure whenever we're with a furnace product that we select the heat pump thermostat with dual fuel function with our furnace product. Okay, as we take a look at an AVC air handler with a two-stage heat strip, we're going to see that it's very, very similar to the wiring scheme that we've done before. The exception is in the graphic, you'll see at the bottom, we actually have two relays now. We have the 002 relay kit that actually has two relays on it. They're designated the RV relay and the S1 relay, which we'll dig into here shortly in detail. So B from the thermostat goes straight outside just like before. W2 is our second stage auxiliary heat. That'll go from the thermostat to the indoor unit. Now remember, team, the AVC air handler and the furnace products are going to be slightly different in their terminal identification. And you'll see that in a little bit, but it's very, very straightforward. W2 goes to W2. W1 is going to go to W1 and go straight outside to W, just like we had before. In this case, we have a two-stage heat strip on our air handler. Y is our compressor call, just like before. It's going to be the same wiring scheme. C is our 24-volt common, and that's going to go straight through, team, just like we had before. C from the thermostat, C to the indoor product, C to the outdoor product, our 24-volt common. And please remember, team, just like before, the 24-volt hot connection, it strictly goes from the thermostat to the indoor unit. We do not need an R terminal outside on the HMH7 heat pump. G goes to G, that's our fan call. It's the same thing. Now you're going to notice that on the AVC air handler and the TMV furnace, when we get to that in a minute, it has an O terminal. That O terminal is part of an advanced airflow function for cooling mode on the indoor unit. So we have to utilize that O terminal. Now on our conventional, everyday Champion heat pump product, O is reversing valve energized for cooling. But hang on a second. Our HMH7 heat pump, it wires a little bit differently. We're going to be using B terminal, reversing valve energized in the heating mode. But we still have to deal with that O terminal on the air handler or the variable speed indoor furnace product. It has to see that O terminal for some advanced cooling functions like dehumidification and cooling on delay, you know, for humid environments and stuff like that. So we have to have that O terminal energized or dealt with on the variable speed product. That's why we have what we call the RV relay. The second relay on this 002 relay kit, we have to deal with that O terminal. We're going to show you how all that works here shortly. So let's go ahead and wire these things up. So on the RV relay as well as the S1 relay, we're going to take one side of that coil. We'll do A terminal in this example. We're going to take that right up to 24 volt common because we need to be able to have both sides of those relay coils to 24 volt common. The B terminal on the S1 relay, the B terminal or the other side of the relay coil on the S1 terminal, or the S1 relay, excuse me, goes up and ties on to S1 on the heat pump. So basically the S1 relay is going to be our airflow reduction relay. Just like we had before, the common terminal on the S1 relay is going to go to Y. So when we have a compressor call, we're going to have 24 volts to the common terminal on the S1 relay contacts. Normally closed contact. The normally closed contact on the S1 relay goes to our high airflow command on the air handler, Y/Y2. That's 100% airflow. That's our full airflow. And remember, team, we always want to set up our air handlers or our variable speed products for 400 CFM per ton. So if they're hooked up to a 3-ton unit setting outside, we want to make sure that we've got 1200 CFM programmed in on that board for our Y/Y2 call in this example. You'll notice that the normally open contacts on the S1 relay are going to go up and hit our Y1 terminal. Now, this automatically happens on the variable speed product. Whatever you have Y/Y2 programmed to, so let's say it's I'm going to use easy math. Let's say it was 800 CFM on a 2-ton unit. Y/Y2, you have it programmed for 800 CFM. If I get a Y1 call, it's going to be 65% of 800 CFM. So if you take 65% of 800 CFM, that's going to be around 500 CFM or so. So on a Y1 call, we're going to reduce that airflow to 65% of the programmed Y/Y2 call on a variable speed product. Any questions or comments so far on how we've wired up that S1 relay? It looks real familiar because it's the same type of wiring scheme we've done on our other product on that particular relay. Any questions or comments on how that's hooked up? All right, team, at this time, let's go ahead and take a look at that RV relay. So the B terminal of the RV relay is going to be energized anytime we have a call for heating mode on the heat pump. Let me say that one more time. The B terminal on the RV relay will be energized anytime we call for heat on the B terminal when it energizes the reversing valve on the B terminal in the heating mode of operation. So if the thermostat calls for heat, we energize B terminal, we energize the reversing valve for heating outside on the HMH heat pump, and then we switch that relay on the RV relay. Now watch this. The common terminal on the RV relay is going to be hooked directly to the hot wire, the 24 volt hot, the R terminal, so it's going to be hot all the time. The normally closed contact is going to be hooked to O. So in the cooling mode of operation, if the unit's calling for cooling, in other words, the B terminal on the thermostat is not energized for heating for the reversing valve, the default position for this is cooling. Once the thermostat calls for heating operation, it's going to switch that relay, the RV relay, and it's going to break the O terminal. So in other words, we're going to take O terminal away during heating mode. Oh, gee whiz, that's exactly what we do with any of our other products too. Anytime we go into the heating mode of operation, we de-energize the reversing valve and we tell the indoor unit it's in the heating mode. That's all that RV relay does, team, is it mimics what happens to just a normal heat pump operation. So again, this is this relay just allows us to use the HMH heat pump outside with a little different wiring scheme on the reversing valve energized for heat, but we use our standard indoor product. Isn't that about the coolest thing in the world? So we have this really cool heat pump outside, wires a little bit different, no big deal, and we use our standard Champion variable speed air handler or variable speed furnace inside, because all it knows is it's hooked up to a heat pump. We're going to give it all the signals it needs to operate properly. Very, very, very straightforward. Any questions or comments on how we're hooking up these relays electrically? Because here shortly, we're going to switch the animation again and give you the animation and show you how all this stuff works together. Any questions or comments briefly?
Joel, I have a question for you. Where do you recommend the relay or relays be placed inside the gas furnace and or air handler?
That's a really good question. I think if you actually take a look at the install information that comes with that relay pack, it recommends you just mount it right inside on the cabinet, inside the blower housing area.
Okay.
And so if you've got room to, they want it in the blower housing area because that's going to be kind of the driest area, I suppose, as well as the most stable is basically in the return air pass. So anywhere inside that cabinet is recommended.
Right. Okay. Thank you.
Good question. That was an excellent question. All right, team, let's go ahead and start looking at some of the animations. We're going to notice real quickly that the TMV furnace, the low voltage wiring is going to be exactly like the AVC air handler that we just covered, but you're going to notice that the W/W1 terminal on the furnace is a little bit different. But as far as the TMV furnace, it's going to wire exactly like our AV air handler, AVC air handler, but you're going to just notice that the heat terminals are slightly labeled differently. So instead of like W2 and W1 on the air handler, we have W2 and W/W1 on the furnace. And please remember also just a little tidbit before we do the animation that the furnace has to have a dual fuel capable thermostat. We just wanted to make sure everybody understood that too. Remember, anytime you apply a furnace product, make sure it's dual fuel and it has that BO selection for reversing valve heating mode of operation. All right, now let's take a look at some animations. So let's go ahead and look at the S1 relay first. So in other words, the outdoor unit has made some intelligent decision and says, hey, give me reduced airflow, and we're in the cooling mode of operation. We notice that the RV relay is feeding power to the O terminal, so the indoor unit thinks it's in the cooling mode because it is. And the outdoor unit says, hey, let's make some intelligent decisions. I want reduced airflow. You'll notice that we switched the S1 relay from normally closed to normally open, and we're commanding now low Y1 airflow, our 65% airflow in this example in the cooling mode. Then let's look at the animation in the heating mode of operation. When we have a B input from the thermostat, the RV relay is going to be energized in the heating mode. So we're going to energize the reversing valve outside in heating mode. The heat pump is now in the heating mode of operation. You'll notice that we've energized the RV relay. We've switched that relay, those contacts, and we've de-energized the O terminal. And the variable speed indoor product now says, oh, I'm in the heating mode. I don't have an O terminal. So I'm going to ignore some of those advanced functions as far as like cooling on delay and some of those other functions on the variable speed product, those comfort enhancement things that when we go into the heating mode of operation, we don't have the cooling on delay anymore because, well, it's in the heating mode. So you cats get the idea. So this relay, the RV relay, the only thing that RV relay is doing on, let me stress one more time, the 002 kit, the only thing that RV relay is doing is dropping out the O terminal in the heating mode of operation so that the indoor product knows it's in the heating mode on the variable speed indoor product. Any questions or comments on the relay function or the relay logic and the low voltage wiring that we've discussed this morning? There's a couple little points we want to talk about. We want to have some reminders on some airflow considerations here in a minute or two. But any questions or comments on how this is working and how the HMH heat pump is commanding low airflow or reduced airflow when it reduces capacity as it makes intelligent decisions outside? Everybody good?
Yep, good to go.
Okay. Well, team, one of the things I want to really stress, this is so very, very important, that the HMH7 has got a lot of capability. It's going to come in whole tonnages, 2, 3, 4, and 5 tons. But one of the most important things on every install is to confirm proper airflow. I just can't stress this enough. The HMH7 is a modulating capacity unit, and you have to provide that nominal airflow. It's just so very, very critical. So duct sizing and ductwork has to be able to provide 400 CFM per ton of total capacity. So even though this thing is reducing airflow and so on as needed, for reduced capacity, we still have to design our ductwork for the full capacity of the unit. So if I have a 3-ton unit, I have to have ductwork that's going to provide a full 1200 CFM when that unit's on high speed or when it's calling for full capacity. And it's really, really important. A lot of times we can kind of fudge on the airflow a little bit on older products with just a single speed outdoor unit and just a single speed old capacitor style blower inside. We cannot do this with this product. And here's why. Because if we don't have proper airflow on the indoor coil, what's going to happen, it's going to drive the suction pressure down. If we don't have the proper airflow on the indoor coil, in the cooling mode especially, it's going to drive suction pressure down. It's going to drive liquid pressure down. It's going to drive superheat down. And all of these parameters are going to be constantly monitored by the outdoor unit. So if we have inadequate airflow, now catch this, if we have inadequate airflow on the indoor unit, the outdoor unit is going to respond by reducing its capacity. Let me say that one more time. The outdoor unit, if it sees reduced airflow or if it senses that we have reduced airflow inside because the indoor coil is colder, superheat's lower, suction pressure is lower, and all those parameters that it's monitoring outside, it's going to automatically reduce its capacity. So now watch this. I have lousy airflow inside. I got a 5-ton unit sitting outside. I have lousy airflow inside. It thinks it only has 3 tons of capacity or 4 tons of capacity. What's the outdoor unit going to do? It's going to modulate back to that 3 or 4 tons of capacity. So the unit is going to match the capacity based on the airflow across that indoor coil. And as a result of that, if we don't have proper airflow, the unit thinks it only needs 3.5 tons of capacity inside. So now you got a 5-ton load inside. You have inadequate airflow, but the outdoor unit's doing its job, giving you 3.5 tons of capacity in my example. So please remember, of all the products that we have in our inventory, the most critical one for proper airflow is going to be our modulating capacity units. So this is really, really important. I just wanted to stress that to everybody. You have to have proper airflow if you want this thing to work properly. Any questions or comments on that as we kind of start rounding out our training this morning? We'll go ahead and open up the floor for any questions or comments, and then we'll make sure and house this out on our YouTube training channel this session later on this afternoon. So let's open that floor up for any final questions or comments as we start heading towards the end of our presentation this morning.
Hey, good afternoon, Joel. It's Emily Hunter.
Good afternoon.
I was wondering, or I guess it's still morning, sorry. But wondering, is there any limitations that we have with this unit or any special piping issues we might run across?
That is an absolutely excellent question. And so the answer is no. I want you to treat this as just a normal heat pump unit outside. And so, look at your suction line and your liquid line. You're going to pipe it just like you normally would, with the proper size suction line. Now, of course, if you have long line applications, we're going to ask that you, look at our piping application guide, or certainly please give me a call. I can help you with that as well. But, up to about, 35 to 50 feet, just a normal line set. Just pipe it up just like you normally would, but please follow all the normal installation practices that are going to be necessary as far as keeping that refrigerant line super clean. Use nitrogen when you braze those lines up. Give me a good double evacuation when you get ready to charge the unit up. Make sure and give me a good double evacuation. We recommend at least 500 microns on the vacuum or less. Just keep it clean, keep it dry, charge it properly, and you're going to have a great running piece of equipment. Thank you for that good question.
Certainly. As well as, you mentioned it was modulating. We used to say the TH16 was 5-stage. Is this 100 stages, 3 stages, 5?
That's an excellent question. I was watching our factory HMH7 video streaming yesterday, And what this thing does is it modulates from about 50% capacity on up. But what it does, instead of being in like 5 to 6 steps, I noticed that during the presentation, what it's doing is actually varying the frequency to that compressor. And I actually observed myself everything from like 25 to 30 hertz, when it was at low modulation, all the way up to like 82 or maybe 72 hertz during that presentation. So what this thing does, it truly is looking at the capacity of the refrigeration cycle and making intelligent decisions. So I don't really know if it's the way to think about it is actually, 50%, 55, and so on. I think a better way to think about it is it's constantly monitoring the indoor airflow conditions. That's why it's so critical to have the proper airflow. It's constantly monitoring the suction line temperature and all that stuff. Oh, and by the way, along that line of thinking, the outdoor unit actually has an EEV in it, or an electronic expansion valve, to really match capacity, even though our indoor expansion valve is just a standard plain Jane expansion valve on that indoor air handler or furnace coil. But the outdoor unit has an electronic expansion valve, so it's sitting there tweaking continually its capacity. So in answer to that good question, it's probably around 50% or maybe 60% on the low end, and then it's going to modulate on up to 100 or 105%. I think there's a little overdrive capability on the thing, strictly, based on the intelligence of that board. So that's an excellent question, but it is not a distinct, 50, 60, 70, 80% like our HMH, or excuse me, like our TH16 was. This is more of a true modulating through that range based on capacity and based on based on the outdoor temperatures and so on. So yeah, great question. Any other good questions or comments?
Joel, can you give a recommendation if this is a replacement system and it's going to be installed on an existing duct system, little things that maybe the contractor needs to look out for, and or recommendations on what needs to be changed or remodeled or whatever on the duct system, so we're not running into the situation that you described earlier?
Yes, that's a great question, Bobby. So basically what I'm going to recommend the contractor does is really take a good study, and they may not have to completely replace the entire duct system. They could maybe just do a makeover on it, so to speak. But I'm going to recommend that they make sure that they have plenty of return, and even to the point if they have to cut in some extra return, that'd be just a great rule of thumb. Give me plenty of return. And when they're building that duct system out, I'm going to recommend that they do not exceed about 700 feet a minute velocity on that main trunk. And on that return, they do not exceed about 300 to 350 feet a minute velocity across that return. So if they need to open that return up, that's probably going to be the big one, Bobby, to that good question. Give me plenty of return, and just make sure that, we've got, we don't exceed about 700 feet a minute velocity on that main trunk, and they should be okay. Good question. Good question.
And then second question, are you thinking of having your duct design course anytime soon so that we can understand a little bit more about 700 feet per minute and really how that affects the system and so forth, especially on these modulating type systems?
Absolutely. I just recently, I say recently, within the last 6 months or so, we've made some revisions on our airflow and duct design class, Bobby, and we can offer that class in a modular format to where it's like about 45 minutes over 4 modules, or we could do the full thing in about 3.5 hours. So by all means, we're ready to have that class anytime that our customers want to do that. So absolutely. So we can start advertising that and recommending that. With all of our champion team. But yeah, we're ready to do a airflow class anytime. Good.
Hey, Joel, it's Jess. How are you?
Good morning.
Good morning. Quick question. What adapter is required?
That's an excellent question. So if you take a look at the service adapter, it's going to be a 5/16 female flare adapter and down to a 1/4 inch male flare adapter for the service hoses. And so those Robinair, JB Industries, Yellow Jacket, they all make those little adapters. Those are pretty common. As a matter of fact, they're the same adapter I think we use most mini splits used. So if the contractors are working on mini splits, they probably have 2 or 3 of those in their tool pouch right now. But it's 5/16 female flare down to 1/4 inch male flare hose adapter. Good, excellent question. Any other good questions or comments?
Hey, Joel, great job of explaining all the various wiring configurations on all this for the install. There's, sometimes troubleshooting these modulating systems is a little tricky. And so do you plan to have any kind of follow-up classes on that? I know there's some very nice onboard diagnostics in a display board, they call it. And I suppose when, if a contractor is contacting our technical support, that they'll be asking for some of these readings, and some of them are pretty intricate as far as the information that this board will provide.
Yes, that's a good question, Tony. So basically, I had gone out yesterday just to see what we had out there on our Navigator lab streaming training sessions. And our factory team, Scott Nelmark and his team, have actually produced a pretty good video. It's about 19, 20 minutes long or so. You go to Navigator, go to Training tab, and then I think it was housed under, I think I found it under Academy TV. And it's a HMH7 overview of all the things that you just said. So one of our specialists down there, they've actually done a training video about 5 days ago. As a matter of fact, they put it out there, and that's actually a pretty good video. I'm going to recommend everybody takes a look at that. But if and when we get the opportunity to actually get my hands on a real live piece of equipment, we could certainly make another video of a how-to video. But that's a nice video they have out there right now. He goes in, the specialist goes in, he talks about the control board, he gets into different parameters and alarms and errors and stuff, and how to get into all that, temperature probes and stuff like that. So that's really a nice little video to kind of get everybody kicked off. In addition, everything that they're doing on that video is in the install information that's going to come with the equipment as far as the technical guide. And by all means, Tony, to your point, if we get the opportunity to actually get on a real live piece of equipment, we could certainly cut a video of a how-to, what buttons to poke and all that kind of stuff. So good question.
Good. And then the other thing, the unit really does have some great capabilities as far as extended line lengths, and that's covered in the install instructions. They also cover in their recommendations on an oil trap when you have an indoor unit that's lower than the outdoor unit. And so it's just something that, some contractors, they're just not used to that. So maybe something to point out to your contractors. Absolutely.
And one other little tidbit that I found from the lab streaming session yesterday, it's not a big deal because everybody has smartphones, but I found out something yesterday that's just a little something to think about. And all of the displays, the temperature displays and the sensor displays on the unit are in Celsius. And you can't default or you can't select Fahrenheit. It's just a little tidbit. But just for everyone's information, make sure you got your smartphone handy, or ask Siri, take your phone and say, hey, what's the conversion for this, and so on. But it's all in Celsius. So just please remember that when you're taking a look at those parameters. If it says, if it says 20 degrees, or if it says 25 degrees, just remember you have to convert that to Fahrenheit. So that's just a little tidbit on that, to your point. Good. Any other good questions or comments, team, before we secure for the morning?
Hey, Joel, just to kind of, you and I talked about this as you educated me, but just with this huge heat wave, in southwest North Vegas hitting 134 or 130 or something like that, even though this inverter, you want to just briefly about the capacity issue?
Yeah, and to your point, Dave, when you start getting above about 120, 110 degrees outdoor ambient temperatures and high altitude, I want to stress that it doesn't affect the refrigeration cycle directly per se, but high, thin air, hot outside, what happens is there is you're going to have some capacity issues, to Dave's good question. So basically, if you're in Arizona, New Mexico, the high deserts of, southern Colorado, whatever, get into Las Cruces or Tucson or whatever, those types of areas, Las Vegas, we're going to recommend that if you're kind of in between, if you have if the load on the house is like 4.25 tons or 4.5 tons or whatever, please be sure and upsize to the next full size, to Dave's good point, because we know that the higher and the hotter it gets, you're going to have a reduction in capacity. But that's the basic science with any air-to-air type of heat pump or air-to-air type of air conditioning system, that high and hot, you have to make those considerations because of the thinness, or how thin the air is when it's real hot outside, and capacity issues. So please keep that in perspective as well. If you're falling in between two tonnages, upsize to the next one, especially if you're in an environment like what Dave was asking about. Good question. Any other good questions or comments this morning? Team, I want to thank everyone for your attendance this morning. It's been an absolute pleasure to train with everyone this morning. And as I said, we will go ahead and plan on getting this recorded session out on our YouTube training channel. And the way you'll be able to identify this, we're going to have a date code on it. So it'll be like 06/17/2021 at the end of the title. This is going to be titled HMH7 17 SEER Overview, and then the date code. So you'll be able to go out and look at this as many times as you like. I'll be sure and add, and all of my champion team will be sure and make sure that you've got the link again today in an email when we announce that it's out there on YouTube. And if there's no further questions, I'm going to go ahead and secure for the day, and we'll stop our training session. And with any final questions or comments, as we start to round out our session, is there any final questions or comments that we could address for everyone before we secure for today?
Excellent job, Joe.
Yeah, thank you, Joel.
Absolutely. Thank you.